Hey, what up guys, welcome back to my channel. And today I have a very special video for you that I think many of you will enjoy, because we will namely be building a blockchain in under 15 minutes. Because I want to demonstrate to you guys that blockchain in itself is a very simple concept. It's a very simple data structure at its core. Of course, cryptocurrencies are complicated, but the blockchain is not the reason they are complicated. The reason why they are complicated is the consensus algorithm. It's the mining, it's the transactions, it's everything that is around. But blockchain in itself is very easy to understand. What you need to know before you can actually understand what blockchain is and how it works, you need to know what hashes are, and you need to know how they work. And so a hash is basically a digital signature of some kind of data. So for example, I can take a movie and I can hash it and get a digital signature. I can take an email and I can hash it and get a digital signature. I can take a word and I can hash it. I can take a whatever data, you just take it, you hash it, and you get the digital signature for that data. So before we start with the actual blockchain, let me just demonstrate it to you how this works. So we will be building our blockchain in Java. It will be very simple, and if you know programming, you can do it in another language. And if you don't know programming, I think you still will be able to understand roughly how this works. So let's talk about hashes. As we can see, guys, we have two lists. We have one list that contains A, B, C, and we have a second list that also contains A, B, and C. So this is the data. This is basically the strings we're trying to hash. So let's see what kind of digital signature we will get from list one, and what kind of so we will just print the digital signature or the hash. Whenever you hear hash, guys, you can just think, you can replace hash with digital signature. So let's see what kind of output we get if we print the digital signature of A and digital signature of list 1 and digital signature of list 2. So as you can see, guys, we get these two numbers, and the digital signatures are identical for these two lists. If I now change anything in list 2, for example, and I run it again, you see that I get a completely different digital signature. So if I just make a small amendment, I just meddle with the data, I try to change anything in this list, I will get a completely different digital signature. And that is the foundation of a blockchain, because a blockchain is a list of blocks, basically a chain of blocks, and each block holds the digital signature of the previous block. And the digital signature of the next block is based upon the digital signature of the current block. So they are all based together. The next signature will be based on the current signature, and the current signature is based on the previous signature. So if you change anything back in the past, you will break all of the signatures. They will look completely different. And I'm trying to adjust the lighting. I should get some kind of artificial light so I don't need to use the window as the light source. Okay, so now that we understand what digital signatures are, hashes and digital signatures is basically the same word, and how you use them, let's actually get into our blockchain coding, and let's see if I can make it in under 15 minutes. So the first thing we need to do is talk about our block. Our block in this case will be very simple. It will only contain three things. It will contain the list of transactions that happened in that block. It will contain the previous hash, the hash or the digital signature of the previous block. And it will also contain the hash of the current of itself. And this hash will be based on the transactions and the previous hash. So if anyone would change anything in the previous block, the digital signature of the current block will change, and when that changes, the digital signature of the next block will change. You will see how this works very soon, guys. So let me just remove this class that I played around with earlier. Let me see, delete, and let's start from scratch, and we will create a new class, and it will be the block. So I'm doing it in Java. You can do it in whatever language you want. It's basically simple stuff. So let's create the fields. It will have the previous hash. It will have the it will have the previous hash, and it will have the transactions. list of transactions. So I'm just making an array of strings, so each transaction will be a string in this case. Of course, in a real blockchain, the transactions would be their own objects, and we will need to create a object for that and define a class and all of that. But we're just playing around. Let's just create them as strings. So, and each block will also have its own hash. And this hash will be based on the transactions. Let me just define the array on which we will base the hash. So we first of all need to calculate the hash of the transactions. Transactions. Let me add an S here, an S here, and an S here, and here, and also here. So we will calculate the current hash based on the hash of all of the transactions and the previous hash, like this. And so the block hash will be the digital signature, or the hash, however you want to call it, of contents. And contents are the hash of the transactions that are in this block and the previous hash, the hash of the previous block. So if I change anything in the transactions, or if I change anything in the transactions in the previous block, or anything in the transactions in the block before the previous block, this hash will be completely different. And here we also need to change. Okay, very good, guys. We have finished our block. Let's create the blockchain. An array list of blocks. So it's basically an array of blocks. An array list is just easier to work with. Let's see, blockchain, and it will be just a new array list like this. So we need to create our genesis block, because each blockchain needs a genesis block that is hard coded. The reason is because, as you can see, guys, each block has the hash of the previous block. However, the genesis block is the first block, so it has no previous block. So we need to hard code how it looks like. So genesis, let's call it genesis block. It will be a new block, and let's see what kind of things. It needs a previous hash, which we don't have, and it needs transactions. So let's just make fake transactions here. Genesis transactions, and they are equal to, for example, let's say Satoshi sent Ivan 10 Bitcoin. So I'm just writing the transactions as strings. Of course, in a real blockchain, this will be some other data structure, probably some kind of transaction class. But for simplicity, let's just write them as strings. Send 10 Bitcoins to Ivan. So everyone is sending me Bitcoin in this Genesis block. So I add it like this. So guys, now we can actually output the get block hash. Let's see. We need to create a getter for the block hash. So now we can actually output. Now we come on. Yes. Now we can actually output the digital signature of the block we just created. Block hash. Let's see what it looks like. So as we can see, I get this number that is negative minus something. So this is the digital signature of this block that we just created. Now, if I change anything at all in this block, let's say that I want to cheat the system, and I suddenly say that Satoshi sent me 1 million Bitcoin, or like 100,000 Bitcoin. And if I run this now, we will see that the digital signature is completely different. And this is very important, because when we create our second block, let's create our second block. It will need first of all, it will need the previous hash. It will need the hash of the previous block, and that is the Genesis block, blockchain hash, and it will need some kind of transactions. Let's see. Let's say that block 2 transactions. Let's say that in the second block, Ivan sent 10 Bitcoin to Satoshi. I sent him back his bitcoins, and Satoshi sent 10 bitcoin to Starbucks. Like this. So these are the transactions in the second block. So guys, as you can see, if I put the transactions and we output now the digital signature of the second block, let's just do like this. Hash of block 2, hash of Genesis block. So now we can actually output the hash of block 2 and the Genesis block. Something is, oh yeah, I forgot new. Let's see. Let me shrink myself here. So as we can see, hash of the Genesis block is this number, hash of block 2 is this number. Now guys, here is the interesting part, that if I change anything in block 1, for example, let's say I suddenly say that Satoshi sent me this many bitcoins, and I run it, you will see that these numbers will be completely different. As you can see, the hash of Genesis block is completely different, and the hash of the second block is completely different. And so this is the basic foundation of the blockchain, that if I change anything back here, the next block will get a completely different signature. And that is because we're passing the previous hash, and we are calculating the current hash based on the previous hash and the transactions. So if I change anything in the past, the transactions will be different, the hash of the transactions will be different, and this change will propagate through the blockchain. And so let's just create a third block like this. Let's say block 3 transactions and block 3, and now we have the previous hash will be block 2, and the transactions will be block 3 transactions. And let's say that in this block I sent 1 bitcoin to my mom like this, or let's give her this many bitcoins, and if I get the digital signature of that, let's see, block 3 like this, and we run it, I get the following signatures. So I just want to demonstrate to you guys now that if I change anything in the first block, let's say that I add this A, I just change anything in these strings, as you can see, it's completely different signatures in all of these steps. And this hashing algorithm is very hard to crack, and the more blocks are created on top of one block, the transactions in that block are more and more confirmed, because it's harder and harder to crack all of these hashes, because the previous hash will be based on the hash before that, and the current hash will be based on the previous hash. And so, as you can see, a change in any of these transactions, in any of the data in one block, will propagate and change all of the digital signatures in the future. And that is how a blockchain works, because if I change something, everyone else will see that my digital signatures are completely different from everyone else's. So that means that I have cheated. So if I just tell everyone that, hey, Satoshi gave me this many bitcoins back then, and here is the blockchain that confirms that, everyone will take a look at it and say, well, Ivan, no, this blockchain doesn't confirm that, because we have our own versions of the blockchain and the digital signatures are completely different. So guys, I hope you enjoyed. I hope you understood the basic concepts of hashing, of linking blocks together via their digital signatures or the hashes. And if you are a new viewer and you like blockchain technology, Ethereum, programming, software development, you should definitely subscribe to this channel, guys, because you will find it interesting. I myself am a software developer, and I'll see you guys tomorrow. I hope you really know how blockchain works and how the concepts behind it. Have a good day, guys. Goodbye.